welcome back to my YouTube channel, Gita Saraswati. In this video, we will learn about sets, relations, and functions. Before that, don't forget to like, comment, and subscribe. So, let's enjoy learning. For the first, set. The definition of set. A set is a collection of objects that can be clearly defined and measured so that it can be known whether or not they are included in a certain set. So, the member of set is clear. But there is also what is called non-set. If it is not a set, it means that its member cannot be clearly determined and cannot be measured. We can see examples of set and non-set. Examples of set: the first, rainbow color set. Second, the set of natural numbers. And then, the set of prime numbers between 20 and 50. And examples of non-set: the first, an interesting collection of paintings. Because the meaning of the word interesting varies according to each person. Second, the set of intelligent people. Because there is no definite measure to measure someone's intelligence. And then, delicious food sets. Because the meaning of the word delicious varies according to each person. The set is usually represented by a capital letter. For members of the set, it is usually enclosed in curly braces, and each member is separated by a comma. Keep in mind, members of the set cannot be the same. Sets can be expressed in three forms. First, with words. Example, A is the set of natural numbers between 1 and 5. Write then, A equals natural numbers between 1 and 5. Second, with set forming notation. Example, A is the set of natural numbers between 1 and 5. Write then, A equals x is such that x is greater than 1, less than 5, where x is the member of the set natural numbers. And then, by registering its members. Example, A is the set of natural numbers between 1 and 5. Write then, A equals 2, 3, 4. There are some important terms in the set. 1. Cardinality. Cardinality is the number of members of a different association. To express the number of different members in a set using the notation n. An example is to determine the number of members of the set A equals the letters forming the word careful. This means that you answer in the way NA equals 7. 2. The set of universes. The set of universes is the set of all elements which are the object of discussion. The set of universes is denoted by S. Example, S equals natural numbers. 3. Empty set. An empty set is a set that has no members, denoted by this or this. Example, X is the set of natural numbers that are less than 1. So, X equals this. 4. A Venn diagram. A Venn diagram is a set image to express the relation between several sets. For the last, subset. Subsets are the set containing other set. A is a subset of B if all members of A are members of B. The notation is A subset B, or this. There are several operations on the set, including intersection of sets, union of sets, complement of sets, etc. For the next, relations and functions. The definition of relations: Relations is a mathematical sentence that states the relation between a member of the set and other member of the set. Set A and set B are said to have a relation if there are members of the set that are paired with each other. Way to express the relations is an arrow diagram, the set of consecutive pairs, and Cartesian diagram. Example, note A equals 1, 2, 3, B equals ABC. Specify A the factor of arrow diagram, B set of consecutive pairs, C Cartesian diagram. The answer is A the factor of arrow diagrams like this. A 1, 2, 3, B ABC. 1 factor of A, 1 factor of B, 2 factor of B, and the other. And then B set of consecutive pairs. 1, A. The meaning is 1 factor of A. And then 1, B, 2, B, 3, B, and 3, C. And then C Cartesian diagram like this. 1 factor of A, 1 factor of B, 2 factor of B, and the other. Next, relations characteristics. 1. Reflexive. The relation R on set A is reflexive if A, element R for every A element A. 2. Symmetrical. Relation R on set A is symmetrical if A, B element R, then B, A element R for all A, B element A. 3. Antisymmetric. Relation R on set A is called antisymmetric if A, B element R and B, A element R, then A equals B for all A, B element A. 4. Transitive. Relation R on set A is called transitive if A, B element R and B, C element R, then A, C element R for all A, B, C element A. Okay, now about function. The definition of functions. A function is a relation from set A to set B if each member of set A match exactly one member of set B. All members of set A or area of origin are called domains, while all members of set B or friendly regions are called codomains. The result of the mapping between domains and codomains is called the function ring or result area. As with relations, functions can also be represented in the form of arrow diagrams, consecutive sets of pairs, and with Cartesian diagrams. Example, you can see the arrow diagrams. So, from the arrow diagrams can be concluded domain is A equals 1, 2, 3, codomain is B equals 1, 2, 3, 4, and function ring equals 2, 3, 4. A function can be denoted by lowercase letters like f, g, h. For example, function f maps set A to set B, then f A to B. Next, functions characteristics. 1. Injective function or one-on-one. If the function f A to B, each B element B has only one friend in A, then the function is called a one-on-one or injective function. You can see this example. 2. The subjective function or onto. In the function f A to B, every time B element B has a friend in A, then f is called a subjective function or onto. You can see this example. And the last, the bijective function or one-to-one correspondence. A function that is both injective and surjective is called a bijective function or one-to-one correspondence. You can see this example. For example, given the domain of the function fx 3x minus 1, x is such that x is less than 5, where x is the member of the set natural numbers. Result area of function f is blank blank blank. So, the answer is domain is x equals 1, 2, 3, 4, fx 3x minus 1. So, y equals 3x minus 1. X equals 1, then y equals 3 multiplied 1 minus 1 equals 2. X equals 2, then y equals 3 multiplied 2 minus 1 equals 5. X equals 3, then y equals 3 multiplied 3 minus 1 equals 8. X equals 4, then y equals 3 multiplied 4 minus 1 equals 11. So, result area of function f is 2, 5, 8, and 11. Okay, that's all about sets, relations, and functions. Once again, don't forget to like, comment, and subscribe. Bye-bye!